Hello, this is Mr. Agbamu Idanogrene. In today's class, I want to show you how you can differentiate a function from first principle. If you recall, in our last class, I said when you are asked to differentiate from first principle, all you need to do is to find the delta y over delta x, which is delta y over delta x of a function. So this is what I say you should do. Then it should be equals to, you now find the function of x plus delta x, okay, x plus delta x, then minus function of x, then you divide it by delta x. So this was what I said in that class. Then after you do this, then delta x is approaching 0. As delta x approaches 0, then you get the limit of delta x when it approaches 0. So that is all you need to do. So your final answer will now be dy dx. Y dx now is going to be equals to, you get the limit of the function, which is the limit of delta x, limit of delta y divided by delta x when delta x approaches 0. So this was what I did in our last class. So if you have this basic knowledge, you can differentiate a function from first principle. Okay, let's look at this example. Let's take this example. Let's see what we can do. Okay, so if I take my first example here. Okay, for example, let's say we have a function like y. Okay, let's take a function y is equals to, let's say, x squared. For example, let's start with this simple one. Let's take a function y is equals to x squared. Remember, this is a function. Then what are we going to do? We want to solve it from first principle. So we said x, which is the change in x, you are going to use delta x to represent change in x, which is x2 minus x1. Then since we are making x2 the subject, you recall our last class, then this x, we need to replace it with this value here, which is x plus delta x. So that will replace this. The same thing with y. Since y is going to be, the change in y is going to be delta y, so we are going to replace y with y plus delta y. So that's what we are going to do. The same thing we did here. X plus delta x will replace x, then y plus delta y will replace y, so that we'll end up in this format. That is our target. So what are we going to do? What we need to do next now is, you said y plus delta y plus delta y, we're going to make it equals to, because the x is having power, then you need to replace it with, you need to put it in bracket, which is x plus delta x, then put the power 2 outside, raised to power 2. So this is the first thing you need to do. You remove x, replace it with x plus delta x. You remove y, replace it with y plus delta y. Why are we doing this? Remember, in the derivation, when I derived this in our last class, I used change in x to be delta x, then change in y to be delta y. So you need to replace both of them. Then the next thing is, I need to take the value of y to this other side of this expression, which is the same thing as the function. You remember we did it. The function itself is y1. No, this is y1 now. Then you now take it to the other side, which is y2 minus y1. Just get the approach. Then that will be our next step. Then which is now delta y will now be equals to, then you have your open bracket x plus x plus delta x plus delta x raised to power 2, then minus y is going to be on that side. That is it. Then since y is the question now, y is equal to x squared, this is what they asked us to differentiate. Remember that. Remember they said differentiate from first principle. Let me put it in statement. To differentiate from first principle. So that is what this question says. Y equals to x squared, differentiate from first principle. So that's why we are doing this. Then we just take y to the other side of the equation. You have this. Then in your next step now, you are going to have your delta y will be equals to, then you can expand this. Since we know how to expand this now, you can expand this bracket, which is x squared. When you expand the bracket, you're going to have x squared plus then 2 times x times ds, which is 2x delta x. When you expand this bracket, I'm expanding this bracket, that's what I'm doing now, then plus delta x square. So that is it. Then minus y. What is the value of y? Y in the question is x squared. Then you put x squared there, equals to x squared. Then that is 1. Then the next thing we need to do now is, remember, the next approach is to divide by delta x. No, we have added this one from the beginning. Then this y we have subtracted it, which is minus x squared. The next thing is to divide by delta x. So we divide both sides by delta x, so that we end up in this format before we get the limit, and that is the end of the solution. So if we go to the next line, when we divide by delta x, we are going to have our value for delta y now divided by delta x, and this value will be equals to, so if you watch well, you will see that x squared minus x squared, they are like terms. So x squared will subtract x squared, leaving us with 0. So we are now left with 2x delta x. 2x delta x plus delta x squared. So you can see, so x squared, I've already cancelled out x squared, turned to 0, so we don't need to repeat it again. Then divided by delta x. So that is this stage. Now we are in this stage now. Then we can still do one more simplification. Then when we simplify this, okay, let me move this down a little so that you can see it well. Okay. So when we simplify this, you will see that we are going to get delta s. We cancel out delta x here, which is giving us delta y divided by delta x, which is equals to 2x plus then x squared, delta x squared divided by delta x to give us delta x. So that is it. Then what next? We now need to get the limit. So we need to get the limit of delta x, which is limit delta x over delta y, delta y over delta x, which is this value 2x, limit of 2x plus delta x when delta x approaches 0. So what does this mean? It means that when delta x approaches 0, when we substitute 0 in this place, don't forget what we said, then this value is going to be equals to the answer we need now, which is the y dx. So that is it. So whatever you have as your limit, that was your final answer. So our final answer for this differentiation now is equals to, final answer is equals to dy dx, dy dx, dy dx is equal, when you substitute delta x as 0, so dy dx will be equals to 2x. So 2x, so that is the answer. So this is how you differentiate a function from first principle. Anywhere you get your x, don't forget, wherever you get your x, replace it with x plus dx. That's what you need to do. Then your y, replace it with y plus dy, because if you remember when we were deriving the derivative function, this expression, we started with putting y2 minus y1 as delta y, then x2 minus x1 as delta x. If you have this approach, you'll see that you are not going to have any problem. So this is all with this example, differentiation from first principle. So I want you to take note of this. Okay, let's try another example with differentiation from first principle. Let me try square root of x. Let's see. Let me take another. Okay, let's take example 2. Let's take example. Let's say we are asked to differentiate something like this. Let's say y equals to square root 3x squared minus 5. Let's say we are asked to differentiate this, differentiate from first principle. It means you are asked to differentiate this from first principle. How are you going to do it? You're still going to apply the same approach like what we did in the previous example. So you start by adding delta y to this side and adding delta x to this side. So that is the first step. So you start, you have your y plus delta y will be equals to, then you have your square root 3, then the x you need to put it in bracket because you are adding x plus delta x plus delta x, then raised to power 2, then minus 5. So this is the first thing you need to do. So take note of that. The values of x and y, you need to add delta x to it and delta y to this side. We are doing this because we need to, because this delta y and the delta x is just giving us the changes that occurs when a value move along the point, along the line. So that is that. And the next step we need to do now is we need to take y to the other side. Then as we take y to the other side of the expression, let's expand this bracket inside the square root. So we are going to have delta y now. So delta y will now be equals to square root. Then when you expand this bracket, you know x squared, then you times by 3. So you are going to have 3x squared. That is the first term of the expansion. Then the next term is 2 times x times delta x. Then 2 times 3 will give us 6. And we are going to have plus 6x delta x. That is the next part of the expansion. Then the last part will now be plus. We are going to have 3 delta x. 3 delta x. Then square. Then minus 5. Then you have minus, we are taking y to the other side, you have minus y. So this is that. Take note of this. So you know what I did here? All I did is to expand this bracket first. When you expand this bracket, you are going to have x squared plus 2x dx plus delta x squared. Then when you open the bracket with 3 times x squared, that's how we have 3x squared. Then 3 times 2x delta x, that's how we have 6x delta x. Then 3 times delta x squared, that's what we have 3 delta x squared. Then minus 5 is outside the bracket, minus 5. Then y, this y has crossed to the other side, it becomes minus. So that is it. Then in our next step, we are going to have delta y will now be equals to square root. Then we need to put the value of y, which is the question now. We need to substitute this value into this place. So we are going to have 3x squared plus 6x delta x, then plus 3 delta x, then delta x squared, then minus 5, then minus square root, then y, replace the value of y, which is 3x squared minus 5. So that is that. Then from here, the next thing we need to do now is we need to divide both sides by delta x. So that is the next step. Then you have your delta x, or delta y. You have your delta y divided by delta x. So this will now be equals to all these values you have here, which is this. All these values. So let's remove this. So all these values divided by delta x. Okay. So this is the next stage. So now that we have divided both sides by delta x, at this stage, if you look at it, there's nothing we can do now. We cannot divide anything. Let's put x in this place. Let's put x in this place. It's delta x. At this stage, you can see that delta x cannot cancel any of the delta x here. No value can subtract any values here. So what do we need to do? So we need to rationalize the numerator. It's only by rationalizing the numerator that is the only way we can simplify this further. So what you need to do now is to rationalize. Just say rationalize the numerator. Remember, in SOLD we usually rationalize the denominator, but in first principle, when you are finding first principle of square root, always rationalize the numerator. It's very, very important, so take note of that. So when you have to rationalize the numerator, you know what we are going to do. The numerator now, this value minus is going to turn to plus, so you are going to multiply the numerator by the numerator and the denominator. So you remember how we rationalize. Let me copy this so that will be fast. Then we have this now. Then we repeat the same thing. Then we are going to multiply now. So times by this itself now, which is, so we remove the bracket. We don't need the bracket. Remove this. Okay. Then the denominator. Then this place will be plus. This place is going to be plus. So this is how we rationalize. You use this same numerator to multiply the numerator and the denominator. So I'm going to put 3x squared now in the denominator. 3x squared plus 6x delta x, then plus 3 delta x square, then minus 5, then plus square root 3x squared minus 5. Yeah, so that is this. Let me move it down a little. Okay, so now that we have done this, so how do we further the simplification? You know, in your difference of two squares, you can see these two values now. We need to expand the numerator. So by expanding the numerator now, if you do it step by step, this number here, this root times this root and this root, it will be too long. So to avoid that, why not just use difference of two squares? And what are we doing in difference of two squares? You remember difference of two squares, you square the ones with root. So this is what you do, the ones with a minus. So this square root and this square root, we are going to square this. Then this square root and this square root, we are going to square it. This is what we do in difference of two square. Then ignore this one with plus, just square the one with minus, then put your result down. Then the denominator delta x will come and multiply this other value. So that's what we are going to do next. So if we square this, what will happen will be the square will cancel out the square root. So we are going to have now delta y divided by delta x divided by delta x. This will now be equals to the only what we have in this inside the bracket will be remaining, which is 3x squared plus 6x delta x, then plus 3 delta x squared, then minus 5. Then you bracket this, don't forget. Okay, we don't even need to bracket it, it's okay. So then we now have minus, then it is this side we are going to bracket. Then open bracket 3x squared minus 5. Because of the minus outside the root, you need to bracket it. Then you are through with this side. Then the next thing is to divide by this result here, which is delta x, then open bracket. You now repeat everything in this place there, which is square root 3x squared plus 6x delta x plus 3 delta x all squared, then minus 5, and plus square root again 3x squared minus 5. Yes, so that is this. Then what next? Then at the next stage now is we are going to open this bracket. Then when we open this bracket, then we can see what can cancel out. Then when they cancel out, then from there we can see delta x. We also cancel out this delta x, and that will lead us to something like this. So when you open this bracket, you are going to get something like this. Remember, minus times plus is minus, then minus times minus is plus. So this minus 5 is going to be plus here. So we are going to have plus here. Then this is what I'm saying. Then you will see that 3x squared minus 3x squared will be 0. So this value will cancel out this value. So these are like terms, they will cancel out. Then minus 5 plus 5 will cancel out, so these two will go, leaving this one alone. Then delta x, this is denominator. You can also cancel out delta x and delta x squared, so leaving 6x in the numerator plus 3 delta x. That's what we are going to that will be left in the numerator. So take note of that. 3x squared minus 3x squared will be 0, they will go. Minus 5 plus 5 will be 0, it will go. Then this delta x, we divide delta x here, and we also divide delta x squared, leaving 6x plus 3 delta x in numerator. So our next step now will now be, the next step we are going to have is now going to be like this. So this one will be off, This one is also off, and this is also off. Then the square will go because delta x I've already cancelled one of the square here, so this will go. Then delta s will also go from here. Then this will also go in the next step, so leaving 6x plus 3 dx. Then this will also go, then this will also go too. Let me adjust it well. Okay, so delta x will also disappear. So this is what we have next. Then from here now, the next thing we need to do is to go to our limit. Now we have successfully removed this delta x from here, and we have cancelled out what is common from here to this. So now we can now take the limit of this value here. So if we take the limit of delta y, delta x, that means any place we have delta x, we are going to add 0 to it. So you put 0 here, put 0 here. So let me take the limit. Here. That will be our next step. So which is the dy dx now, which is dy dx. Dy dx will now be equals to, you take the limit of that function, the limit of delta y, which is the limit of delta y divided by delta x when delta x approaches 0. When delta x approaches 0. So when delta x approaches 0, that means this place is going to be 0. So 3 times 0 will be 0. So this will go. Then this place is going to be 0. 6x times 0, this will go. Then this place is going to be 0. Then 3 times 0 will be 0. So we are now left in this bracket now. We are now left with, so I can even put my answer here. I don't need to go to a new page. So let's just finalize our answer in this place. So finally, we are going to have dy dx, dy dx is now going to be equals to 6x in the numerator is 6x divided by square root 3x square, 3x square minus 5, then plus, you can see this 2 will now turn to 0, leaving 3x square minus 5. So that's what I have here. Then plus square root also, plus this other square root, which is 3x square, 3x square minus 5. Then this is now our answer. This is now our answer. Take note of that. Then to finalize the answer now, you can see that the denominator, these two are like terms. So since they are like terms now, our final answer. So let me conclude now. So final answer now. So final answer will now be dy dx is equals to 6x divided by square root. Let's remove this. You know this denominator, they are like terms. Square root 3x square minus 5 plus square root 3x square minus 5, they are like terms. So we are going to have plus, then okay. So 2 root 3x squared minus 5. So this is our final answer. So that is the answer of this question now. So the differentiation of this one, square root 3x squared minus 5 from first principle, this is the answer if you follow all the steps the same way I did it. So take note of this, and that is all. The major secret about differentiation from first principle, I've told you before, is the inclusion of x plus delta x. Every value of x and every value of y, add delta y to y, add delta x to x, then solve downward following your basic mathematics rules. Then when you are solving downward, don't forget to take y to the other side of the equation, then replace value of y with the question you have. Then when you have done that, if you square root, then when you do that, the next thing is to divide by delta x. Then when you get to this stage, you rationalize the numerator. And after rationalizing the numerator, then you solve it well. Just follow your basic mathematics rules in calculation. You can see that's what I did to get my answer. So take note of that. So let me just confirm this answer I got from this my PTC math card software. Let's see if this answer is correct. Let me define my function. If I take f of x, if I define my function now, I'll define my function as the question. The question we just differentiated now is 3x squared minus 5. This is the function we just differentiated from first principle. If I want to test if this answer I got here is correct, all I need to do, I need to go to my operator here. So you take derivative. So let's take the derivative. I need derivative of this function f of x. So derivative to x. Remember this question here, I call it y. That is why we said the y dx. But I'm telling this system that I'm not calling it y. I'm calling it um, f of x. So that's what I call it. Then if I come to this place, if I use this operator here, see it's solving it. You see the answer I will give to us. We are going to get the same result here. You can see that is it. You can see that the system even did this simplification further. You can see what it did now. It knows that 6 can still divide 2. So 6 divided by 2 is 3. You can see I'm even supposed to go a little bit further with that. So 6 divided by 2 is 3. So that's why the numerator is 3x divided by square root 3x squared minus 5. So you can do that and finalize your work. So which is 3x, let's pull it down, which is 3x divided by, you can see 6 divided by 2 is 3, 3x divided by square root 3x squared minus 5. So this is your final answer, and that is that. You can see with the system solving it, you can see we got the same answer, but this is all the steps you follow when solving differentiation from first principle. So that is all I have for you today. Till next time, we shall do more solution. So everything we did today is this. You can see it. Differentiation from first principle starting from y equals to x squared. You can see the approach I used. There's no problem with that. Then the second question we have here, you can see it, the same thing. So take note of this till we meet in another class.